Hey there, this is me, Mohammed Vamik, your computer science instructor, and this academic year I will be teaching you computer sciences. I believe that together we can explore new opportunities for learning together. I wish best of luck to each and all of you. So, for grade 10's computer sciences, we are initially going to start with the very first chapter that we have is algorithms, design, and problem solving. So, this is going to be basically the first chapter that we are going to discuss, that is algorithm, design, and problem solving. And before starting this chapter, let's discuss that what are some of the key terms that key learning objectives that we have to discuss in today's class. So, first of all, in this class, we need to discuss regarding the program development life cycle. We need to discuss analysis, design, coding, and testing. So, these are the 4 to 5 areas that we will be discussing in today's class. So, initially, before starting the chapter, the name of the chapter is algorithm design and problem solving. So just give me a moment. We will be discussing here the chapter, and the name of the chapter is algorithm design and problem solving. So initially, before getting into this chapter, I just first want to discuss with you regarding the key terms that what do you understand by this term algorithms, right? Like even before starting this, I'm going to break this whole chapter down so it is clearly understandable to you that what are we going to study and what we are going to learn in today's class. So the first area I have right here is definitely an algorithm. So basically, an algorithm is to be known as a sequence of steps in order to solve a problem. Like for example, if you are working into any organization and your boss suddenly calls you and say that this is basically my problem, and that problem could either be like, for example, if you are recording your employees attendance, so that means that you are requested to create a program for your employees attendance. So that is going to be basically the problem of that organization. So how you are going to solve it? You are going to solve it with the help of an algorithm. So what an algorithm is going to do? First of all, you need to understand this term that is to be known as algorithms. It is not like something not like something that you can just create the whole of it at once. Every time you create the algorithms, you create it into step by step. That means if you are making, let me give you an example of blocks. Right, like for example, if you are creating a sort of a building, you combine a lot of little blocks together, and all those little blocks, when they are placed properly, they form the building. Similarly, if I'm talking in terms of an algorithm is basically like small building blocks that creates the piece of the software. That means that the algorithm means that it is the sequence of steps, right? Like for example, step one, step two, step three, step four, step five, and then all together completes an algorithm. So basically, an algorithm is used to give you a solution of a problem by giving you some number of steps. So that is learning number one. What is algorithm? Sequence of steps in order to solve a problem. The second area for this chapter is that we need to discuss that now when you are creating this algorithm, we also need to discuss with you that how you are going to design that. And in designing, we are going to discuss into the chapter that what are the different ways that how you can design that. The third area is basically a problem solving area, and problem solving area basically contains mathematical concepts, right? Different scenarios, how you solve a problem. So this is basically the outlook of this chapter, that what we are going to discuss into that. So let's get into this chapter. So first of all, I just want all of you to think like how a software is developed from beginning to end, right? Like for example, for example, I want all of you to take a piece of paper, to take a piece of pen along with you, and write your findings onto that. Right? Like, for example, okay, so you all need to understand that you all are my future programmers. Now, for example, let's say that if all of us are basically working into an organization or a company, I suddenly called all of you. I asked my team, I am asking my students that you want to develop a software. My problem is that I am unable to track the attendance of my employees. That means I need to create a software that tests that which employee is coming on which time. That is an example of a software, a small piece of software that is tracking the attendance system. So how are you going to develop that from start, from beginning to end? So I want you to take a piece of paper and note down any pointers that comes into your mind, that how you are going to do that. So for this activity, I'm giving you uh, I'm giving you right here 5 minutes to complete your working and then get back to me. So your time starts now. Okay, so I believe that the time's up for the activity, and I also believe that all of you have wonderful answers in your answer scripts that basically tells you that how you develop. So, as far as your answers are concerned, I request all of you to share your answer scripts along with me, along with the MS Teams. So right now we are going to take our lecture beyond to the next stage, and I'm going to discuss with you this basically to be known as a program development life cycle. So we will be discussing in today in the next area the first title of this, which is a program development of the program development life cycle. So, as far as program development lifecycle is concerned, I'm quite sure that all of you might understand the meaning of this term that is to be known as program development. That means that when you want to develop a program or the last work that you completed, that was when you were developing the piece of software from the starting stage to the ending stage. This is what a program development means. That means that when you are creating the software, but right here it says the life cycle. That means that now what I need to do is that I need to work with the life cycle of a software. You would remember that the life cycle of humans, for example, the life cycle of a student, right? Like, for example, there is a student, and first of all, you go to school, you go to college, you go to university, you complete your education, then you go forward your professional career, your corporate job, so then your trainings. So this is basically the life cycle of a student, or I can say someone like us. So that is completing the education and going beyond for their career. But similarly, if I discuss with you that what is going to be the life cycle of a software, what is going to be the life cycle of a program, that how it is developed. This is what we are going to discuss in today's class. And the program development life cycle, that is also known as PDLC, stands for the program development life cycle. It has four different stages, and we are going to discuss the each stage in detail. The first one is your analysis. The second one is your design part. Then the third one is your coding. The fourth area is your testing. So I'm going to explain to you all of you these four categories. So starting with the first one, that is analysis. This is basically a program development life cycle. As you can see here, we have analysis, design, coding, and testing. So if I discuss with you in terms of an analysis, so basically analysis is the first stage. That is when you want to solve a problem. The first thing that you usually do is that you look at the problem and you look at the system that is needed. For example, if I ask you that this is a problem that you need to solve, what you are going to do? First of all, you are going to make an analysis. That analysis means you are going to look at the problem, you are going to look at the things that are needed, you are going to explore it, you are going to look for the requirements of that, and then you are going to discuss that, okay, if this is the problem, then the solutions can be this, and this. Like, for example, if you are giving an exam, and like for example, uh, I requested my class, my students, that you need to give the test. Gave all of you a test paper. So basically, if this is a test paper right in front of you, even before starting the exam, what you usually do is that you first go through the questions, right? Like question number one, question two, question three, question four, question five, and then you look for that which are the questions that you can easily do, which are the questions that are difficult. So what is that? That is basically an analysis. So even before starting to solve the paper, you first make an analysis. Analysis means looking at the problem and then solving it, exploring it, identifying it. In your analysis, now here comes another term that is to be known as a decomposition. In your analysis area, we have a term, and this term is known as decomposition. This is basically a part of your analysis. So basically, if I'm referring to a decomposition basically means that you are splitting the problems into sub problems. For example, if you are having difficulty into computer science, how are you going to solve it? You are going to split it into a number of ways. For example, you are going to focus on your class, you are going to solve the past papers, you are going to focus on the homework, you are going to focus on the activity. Problem was one, but you split it into a number of solutions. So what is decomposition? Decomposition is basically when you split your problem into many sub problems so that it's easier for you to identify it, it's easier for you to work for it. So decomposition is basically like taking a system and splitting it into many smaller areas so that you can solve it. Right? Like analysis. What analysis means, what will be done. Like you are understanding the old system, you are identifying how the old system can be improved, you are developing the specifications for that. Analysis always needs some requirement specification, then it always use two different tools. One the name of the one tool is decomposition, which I have explained you right now. The second one is an abstraction. That is like you have to identify the requirements, right? Right. So for example, uh, decomposition we have discussed it just right now. Decomposition basically means that you are breaking your main problem into a number of tasks so that you can easily work on that. What is decomposition? Decomposition means you are breaking a complex problem into smaller areas and which can be further divided so that you can work onto them. The second tool that is a part of our syllabus is basically abstraction. So now when I'm talking in terms of an abstraction basically means that you are only focusing on what is required. You are only keeping the key elements required for the solution and discarding all unnecessary information that is not required. Like for example, if you are traveling from your home to your school, what do you think? Do you focus on everything? Do you stop on every place that comes in between your school and home? Or your basic target is your school, your destination? For example, I am right now going to my school. So should I be stopping at each and every restaurant? Should I be stopping at each and every shopping mall and entertainment place? Or my only focus is on the school, on my target destination? My focus is only on my target destination, that is a school, and the venues that are coming in between, I have disregarded them. They are not necessary. I have ignored them. So abstraction only means you are keeping a focus only on the end. You are keeping the key elements required for the solution and you are disregarding any unnecessary details. So I hope it's clear to you. The next thing I have right here is basically the design. And design area is something like how the system will actually work. For example, you are working with a user interface design. For example, you are working with a data structure design. For example, uh, when you are working into an organization, maybe your boss called you. Your boss said that my program developer just created the piece of software, but yet its design, its user interface, its color, its look and feel has to be developed. So when you will be developing the user interface, you need to keep into mind the design perspective. A design perspective is something like what is going to come into your reality, right? Like for example, you can here contrast the two areas, that is a design and that is a reality. Perhaps what are you going to write down or create and design is definitely to come going to out into your reality. So the program designers can begin planning how the program will work in this phase, and they can basically say that if the design of the program either have to be created into a flow chart, or either it yet has to be created into a pseudocode. We are going to discuss both of them, that what is a pseudocode and what is a flowchart. For now, you can only understand that a flowchart is basically a pictorial representation design, a visual ad that can help each and everyone to understand that what is actually happening into that. For example, you can see this is a flowchart. You can see the working path, right? Like in which direction the process is going. When it comes to a pseudocode, this is a sort of an algorithm, but we do not call it purely a programming language. So as far as the design area is concerned, a design area is basically the one where program specification from the analysis stage, it shows that how your program has to be developed, and it is documented using the three areas, which I am going to discuss with you in detail, right? Like it can be designed into using a structure chart, it can be designed using a flow chart, it can be designed using a pseudocode. I'm going to discuss the three of the categories, but I think that the flow chart and the pseudocode is right in front of you. This is a flowchart. You can see that it is showing you the progress. It has a start and it is taking you this way. So you can see the actual progress. This is basically a pseudocode. And right here, you can see that pseudocode is not purely a programming language, but it is just a way to describe your algorithm. Pseudocode is just a way to describe your algorithm so that it is easily understandable by each and everyone. And when it comes to structure charts, this diagram right here is an example of a structure design, or you can say even at a structure chart. So you can see that in this structure chart, I have my main problem, and this main problem is being divided into the sub areas. This, and so on, this and this, and so on, this and this. So with these three different ways, I can design an algorithm, right? Like a structure chart, pseudocode, and flow chart. Moving ahead with the third category, I hope that you guys it's completely clear regarding the program development lifecycle analysis part, design part. The third area I have right here is coding. And when it comes to coding, a coding basically means that you are looking for a suitable programming language. You are testing that if it is working or not. And the word here, iterative, basically means repetitive. That means that you are actually repeating again and again to see that if it is actually working or not. You are deciding that which programming language you should be using and which programming language you shouldn't be using, right? Then I have the fourth stage, and the fourth stage is basically testing. So you need to remember one thing is that whenever we are creating softwares, whenever we are creating programs, testing is one of the important area, because in testing we basically test that how that programs actually work, right? Like for example, you are done with your piece of software, you have completed that, but yet if you have not tested it, how would you know that if it is actually working or not? So when it comes to the testing area, it means that you have to test it, that if it is accurately working or not, if it has any errors or not. So, so far, this is it for this area, right? Like we have discussed in detail that what is a program development lifecycle, what is analysis, what is design, what is coding, what is testing. We have discussed, right? Like in analysis, we have two keywords. We have an abstraction, we have decomposition. In design, there can be three different ways we can do that, like decomposition, structure diagram, flowchart, and pseudocode. In the coding part, we can see that how we can write programs, code, and testing. And the last area is your testing one. So I hope that all of this is right clear to you. And just to spice things a little bit up, I'm giving you guys one of the activity, and you need to solve it and again get back to me. So just give me a moment. Okay, so just right here, I have submitted this activity, this scenario file right into MS Teams, and I wish that all of you complete this and submit it to me so that I can check it for answers. So before giving this activity to you, let me share with you that what you have to do in this task. So, first of all, this is basically a scenario activity. So, you are given a scenario. You are tasked with developing a simple student grading program. For example, if it's a student grading program that calculates and displays the final grade of a student based on their marks in three subjects. Those three subjects are like mathematics, science, and English. So this is a piece of software that you have to create, right? But even before creating it, we will be using the PDLC development life cycle. So within to this scenario, I have broken it down into four stages, and within to those four stages, I have given you some set of questions. What I'm expecting from all of you, right, is that you all need to reply to me regarding these, and those answers perhaps does not have to be necessarily too long. For example, if they are one line, two lines, three lines, that's more than enough. Just like you properly deliver them. So you need to create a program, a student grading program that calculates and displays the final grade of a students based on their marks in these three subjects. The first area is that analysis. What is the purpose of that program? You are going to write it the purpose. What inputs will your program need to collect from the user? That means that what are the values your software will collect so that it can calculate a student's grade. For example, marks, for example, grades. What will be the program output be? Output means that what is going to it is generate. So it is definitely generating the grades based on the marks. What are the rules for calculating the final grades? So it's totally up to you, even if you want to calculate the average or if you want to calculate something. The second area right here is design. How will you structure the program to collect the required input? Right? Like for example, you can define here that if you wish to have a structure chart, pseudocode, a flow chart, what calculation will the program need to perform to get the final grade? Let's skip this. How will you display the final grade to the user? You can say like, congratulations, this is your A grade. For example, you can say, oh, you need some practice, you secured an F grade. So you can give messages to your user. Which one do you prefer? It's totally up to you. I'm going to check that what do you reply into that. Either if you want to use a flow chart, a structure chart, or a pseudocode, you can refer to the diagram into my lecture. And no worries if you are not getting any question, just give me your best. I'll be checking it and I'll be getting back to you. So no need to worry at all. In the third area, it says that stage coding. So if you were to write the code, which programming would you use? So we do have different programming languages, right? Like for example, we have Python, we have C Sharp, we have C++, we have other languages as well, Java. So I hope you guys have basic knowledge about the programming language, but it's totally up to you. It's totally your choice, right? What variables would you define? Oh, let's skip this for now. How would you implement the calculation in code? How do you find the average? So for finding the average, the formula is simple. You guys know it already. You are just going to write here that, sir, I'm going to have the sum and that is going to be divided by the number of subjects like this. And then there is the last area. You guys are going to say that in the testing, that what kind of data you will test. So you can actually set some of the examples, right? Like if I'm testing that if the student is getting the correct grade as per the marks or not, how will you check that if the program is correctly working or not? How would you do if your program produces correct results? So it's all up to you. I believe that you guys can do it very well. So don't worry at all. Feel relaxed. No worries if you do it a little wrong. I just want the best of you. So I just want you to share your ideas with me in this exercise. So I have uploaded it in MS Teams. So do complete that and get back to me so that I can continue with our next learning objective. So thank you very much. If you have any queries, please feel free to ask them. I'm right here for solving all your queries. Thank you so much. Thank you very much, everyone.